Hi guys, welcome back to another IBHO math tutorial. This video is actually a continuation of the previous video where we looked at this integral and how to solve it in one step. So I strongly recommend that you guys go ahead and check that video out first before coming here. In the previous video, we basically learned this rule of thumb where in any rational function, if the numerator is a derivative of the denominator, well, the integral of that would be the natural logarithm of the denominator, which is f of x. Yeah, this can be used to speed up many substitution sums, which can help you save a lot of time in the paper. So we can look at tan x here. So in trigonometry, we learned that tan x can be written as sine x over cos x. And in basic differentiation, we probably learned that the derivative of sine x is equal to cos x, and that the derivative of cos x is equal to negative of sine x. The negative sign is very important. So if we look at the integral of tan x dx using this rule here, we can write that as integral of sine x by cos x, making it a rational function. But then we cannot use this rule because the derivative of cos x is negative sine x and we only have a positive sine x. We need a workaround. We need to be able to make this sine x negative sine x. When first learning integration, you probably learned that integral of kx dx is kx dx. So basically you can take the constant and put it outside the integral because the presence of the constant is not gonna affect the outcome. And so we're basically gonna be using this principle to convert our sine x to negative sine x. So just imagine if k is equal to -1, then the integral of negative x dx would be equal to negative outside the integral x dx. So we can write the integral of sine x over cos x as the negative integral negative of negative sine x over cos x. This is the same thing as sine x over cos x. Let's not forget the dx here. This can be written as negative of negative sine x over cos x dx. As you can see, the negative sign is here, which means this satisfies this formula whereby the numerator is a derivative of the denominator as suggested by this. The derivative of cos x is negative sine x, and we have that in the numerator. So now we can simply write the solution as the negative natural logarithm of cos x plus c. But we don't have to leave this here because you can take this one step further. While learning logarithms for the first time, you probably learned that a constant over here can be written as power k. So likewise, we can write this as -1 plus c. You guys have probably learned inverse trigonometric functions where 1 by cos x is equal to secant x. Therefore, ln of secant x plus c, and we have the solution. So yeah, that's basically it. It's really simple and you don't have to really show all this working. You could probably just skip a few steps and like directly achieve this result. Like after a few sums, you'll probably be able to do this in your head. So for these inverse trigonometric functions, there's actually a super simple way of remembering it, because many people get confused between cosecant x and secant x and how it's related to cos x and sin x. So basically the inverse of sin x would be cosecant x. And how I would remember this is s and this is c. The inverse of s is always c. Likewise, the inverse of c is always s. So cos x would be secant x because this is a c and this is an s. So the inverse of cos x is always secant x, and the inverse of secant x is always cos x. So yeah, that's a super simple way of remembering this and never really making a mistake with this with the inverse trigonometric functions. So this was another shortcut which you should probably have in your arsenal, and this can save a lot of time in your papers. Thank you for watching.